Okay, these are video solutions for the Year 9 2008 non-calculator NAPLAN paper. Okay, this is question 1 non-calculator 2008 paper. Jen is making this brick pattern. Shape 1 has 1 brick. We can see shape 2 has 1, 2, 3, 4 bricks. Shape 3, this one, if you count the bricks, we've got 9 bricks. Shape 4 has 16 bricks. How many bricks are needed for shape 5? What we've got to notice here is that there is a pattern between the top row here and the bottom row, 2 and 4, 3 and 9, 4 and 16. And that pattern is that, for example, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So the answer is 5 times 5, or we write that as 5 squared, which is 25. And just noting with the first one, 1 times 1 is 1. So our answer for question 1 is 25. Now this is question 2. This table below shows the lengths and widths of rectangles with an area of 20 centimeters squared. You know, with a rectangle, when you multiply the length times the width, you get the area is length times width, or you may have seen it as length times breadth. Just notice 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20, 5 times 4 is 20, 10 times 2 is 20, 20 times 1 is 20. The question is, which graph shows the information in the table for length against width? So we're looking for when length is 1, width is 20. So let's just have a look here. When, say, length is 1, width is 20, that seems to work. Then when length is 2, roughly about here, width is 10. Now that doesn't seem to be right. So I need, say, length is 2, width is 10. It doesn't seem to be any of those. I think it's this graph here. When length is 1, width is 20. When length is 2, width is 10. When length is 4, width is 5, 5, 4. When length is 10, width is 2. Look, this looks correct. So the answer here is the fourth option, okay, in that bottom right-hand corner. A ramp, this is the ramp, makes an angle of 35 degrees with the ground. What is the value of A? Now we've got a right-angled triangle, and this symbol is a right angle, which is 90 degrees. And there are 180 degrees in a triangle. And so the missing angle will be, A will be 180, take away 90, take away 35. So if the three of them add up to 180, the missing one will be 180, take away the other two, and your answer will be 55 degrees. So just be careful with that, okay? So 180 take away 90 is 90. If you want to take away 35, take away 30, which will give you 60, and take away 5 more, which will give you 55. Okay, that's question 3. Now for question 4. The points Manny scored in his last basketball games are shown there, all the way from 9 up to 30. And he put these scores into a stem and leaf plot. So we've got 3, 0. See, 3, 0 means 30. Then we can see we've got 21, 22, 22. So we've got those. Then we've got 11, 12, 12, 18, and we've got the score 9. Now normally a stem and leaf plot is not written this way. You normally have, how it's normally written is like this, stem, leaf, and you have your 9 up first, and then you've got 11, 12, 12, 18. Then you'd normally go 2, 0 for 20. Then 21, 22, 22, and then we've got 30. So the number that is missing appears to be the 20. Okay, so which score is missing? Don't just put a 0 as your answer. So this 0 is missing, but the score that's actually missing is 20. Okay, so make sure these are the scores in here, so you have to write the missing score. Now for question 5. Which pair of solid objects cannot be joined together to make a cube? With this first solid, you could take this piece, sort of turn it flat, put this piece here over there, and the L, that sort of L shape, can go like that. So this one can be joined to make a cube, so that's not the answer. The other one, with this one, you could turn this piece upside down, and this piece here that I'm shading can go into this spot here, and then those other two would fit there, and the one underneath would be here in the front, so this will also work. So the ones that won't form a cube is either this one here or that one there. So you need to look at those a little bit more closely. This third diagram here, if these two pieces get stood up in there, then these other pieces should wrap around the front there. So that should work. Now, with these last two, these objects are mirror images of each other. Like if you put a line in there, one's the reflection of the other. No matter how you try, if you put these pieces, say here, those other pieces are going to come across. They're actually not going to form backwards there. So I believe the last one, the last pair of solid objects cannot be joined together to make a cube. 6, here is a seating plan for part of an aeroplane. Rob is sitting in window seat number 2A. So Rob is here. So we've got 2 and A. I've just circled where Rob is. Okay, Peter wants to sit in a window seat as close as possible to the front of the plane. Now let's look at the key. All the seats that are shaded are taken. Okay, so this is taken, that's taken. These are the windows. Okay, where the dots are there, they're the windows. And empty seats are blank, and Rob is sitting there. So Peter wants to sit in a window seat as close as possible to the front of the plane. The empty seat that he should choose would be this seat here, because that's a window seat. All these are taken. That's the next closest to the front. So that seat is 3F. Okay, now for question 7. Question 7 is, $1 buys 0.80 US dollars, or 80 cents US, or 0.8 US dollars. How many US dollars could be bought with 50 Australian dollars using this exchange rate? Now, if $1 Australian, I'll just write it as AUD, equals 0.80 US, you could work out, you don't have to go straight to 50. Let's work out what 10 Australian dollars is. So 10 Australian dollars would be this amount times 10. If you're timesing that by 10, you move the decimal place one place to the right, and you would get $8 US, okay? $8 US. And now for 50 Australian dollars, so we're timesing this 10 by 5 to get 50, we would do 8 times 5. So we'd get 8 US times 5, and we would get 40 US dollars. So your answer to this question is 40 US dollars. Okay. The other way you could have done it is go straight from, you could say 1 Australian dollars is 0.8, and then you can go 1 times 50 is 50, 0.8 times 50. So you could have done it like this as well, 0.8 times 50. You could have just done 8 times 50 is 400, but then you've got 1 decimal place in the answer, so you need to bring this back 1 decimal place. I actually think it's easier to do it this way. 1 Australian dollar is 0.8, 10 Australian dollars is 8 US dollars, and then going from 10 to 50 by multiplying by 5. Okay? Okay, now this question says a computer chip has dimensions, so the real size of the computer chip is 8 millimeters by 8 millimeters. And here they've drawn a scale drawing of it. So the drawing that they've drawn of it, now 8 millimeters is quite small. If you get your ruler out, I'll just do that now. So the actual computer chip, this is about 8 millimeters. That's 1 centimeter or 10 millimeters. So 8 millimeters, this is the actual size of the computer chip. It's quite small, okay? So this is the actual size. And this is a scale drawing. Obviously, the drawing that they've drawn is bigger than the actual size of the computer chip. So we're looking at the scale used in the drawing. Now, in the drawing, 4 centimeters represents, so this is the real computer chip, Okay, so 4 centimetres that they've drawn represents 8 millimetres. Okay, looking at all these, why don't we see what 1 centimetre represents? So to go from 4 to 1, you would divide by 4. So we divide this by 4. So 4 centimetre represents 8 millimetres, then 1 centimetre represents 8 divided by 4, which is 2 millimetres. So therefore our answer is the second response there. 1 centimetre represents 2 millimetres.